So lecture notes 23. So solving the quadratic equation using square root property. So let's see the first one. So whenever we solve equations or simplify, we want to simplify it. So this one can be simplified, right? We have one term on the left, or we have one term on the right. And both terms have 3 as a common factor. So we divide by 3. 3x squared divided by 3, we get x squared. 21 divided by 3, get 7. Now we can square root. So let me change my color. So because we have perfect square on the left-hand side, so the variables x has perfect square, so we want to square root, because square root are opposite operation. They cancel each other out. So now when we square root, we got a plus minus 2 values. So x equals to positive square root of 7 and negative square root of 7. So we can write as this. So this means x has 2 solutions. One is radical 7, positive. One is negative radical 7. So what did we do? We simplify the equation by dividing both sides by 3. Then we square root both sides. All right, so let's see B. B, we have 16x squared plus 25. So let's move, because we want to use square root property. Let's move 25 to the other side. So it becomes negative 25. So we have 16x squared equals to negative 25. Now we divide 16 on both sides. So we get x squared equals to negative 25 divided by 16. Now let's square root. So we square root both sides. Get a positive, negative 2 values. X squared square root cancel each other, so just get x. Now we have plus minus 2 values. Well, square root of negative number, remember we defined as I. So square root of negative 1 is I. So get a plus minus I. Square root of 25 is 5. Square root of 16 is 4. So we get 2 solutions as well. But these 2 solutions are complex numbers. So one is a positive, I 5 radical 4, I 5 over 4. And the other one is negative I 5 over 4. If you want, some people write as a 5 over 4, then write I. That's okay too, doesn't matter. Basically, I just represents the square root of negative 1. Now let's see 2. So 2, we want to use the completing the square method. So let's recall perfect square. A plus B squared, that equals to A squared plus 2 times A times B plus B squared. So when we're completing squares, we only take these 2 terms into account. That's to say, take these 2 into account. So we take the number before x, which is 10, we divide by 2. And we figure out B is 5. Right? So in this case, you see A is x, B is 5. Why? Because 10x equals to 2 times x times 5. 2 times A times B, right? 2AB. X is 8. X is 8. So we have x squared. So that's A squared. Then 2 times x times 5. So B is 5. B is 5. So if B is 5, B squared is 25. So we need 25. So we need 25, but we only have 12. So maybe we can plus 13 on both sides. Right? So 12 plus 13, we have 25. Now we have made this side to be x plus 5 squared. Then the other side is 13. Now we can square root both sides. Once we have perfect square on one side, we square root both sides. Square root to get positive, negative two values. So get x plus 5 equals to plus minus square root of 13. Square root cancel out each other. Now we move positive 5 to the right-hand side, becomes negative. So we have two solutions. Negative 5 plus radical 13 and minus 5 minus radical 13. So two irrational solutions. Right, two irrational solutions. Now let's see B. B, we want to make the number before x squared 1. So let's factor out 2. Factor out 2, we have this minus 3x minus 5 over 2. Or maybe you could do this. So just move negative 5 to the other side, become positive 5. Right, become positive 5. Now we divide by 2. So we get x squared minus 3x equals to 5 divided by 2. I intentionally leave some space there after minus 3x because I want to make this side to be a perfect square. So what do? I take negative 3, I divide by 2. So that means then I square this one, I get 9 over 4. Okay, so I want to add 9 over 4 on both sides. And this side now becomes x minus 3 over 2 parentheses squared. And add those two, denominator is 4. 2 times 5, 10. 10 plus 9, 19. Right? So negative 3x is 2 times x times negative 3 over 2. Right? You see B is negative 3 over 2. So I have perfect square form. Now I can square root both sides. So I square root both sides. I get a plus minus 2 values. So I get an x minus 3 over 2 equals to plus minus square root of 19. Well, square root of 4 is 2. So over 2. Then I move negative 3 over 2 to the right-hand side. I also get two irrational solutions. Okay. So number 2, A and B both have two irrational solutions. So that's called completing square. Right. Let's see 3. 3, we want to use a quadratic formula. Let's recall quadratic formula, right? This is ax squared minus 6x plus 3. So we figure out A, B, C. A is a number before x squared. B is a number before x. C is a number itself. So we have figured out A is 1, B is negative 6, C is 3. Then we plug in quadratic formula, which is negative B plus minus square root of B squared minus 4AC divided by 2A. Well, negative B, right? So I have negative 6 plus minus square root of negative 6 squared minus 4 times A is 1 times C, which is 3. All divided by 2 times A, 2 times 1. Simplify this. Negative 6, positive 6. Plus or minus negative 6 squared, 36. 36 minus 4 times 2, 8. 8 times 3, 24. So 36 minus 24. Let's write 36 minus 24. All divided by 2. 6 divided by 2, we get 3. So 3 plus or minus. Well, 36 minus 24, that's square root 12. Square root 12 can be split as the square root of 4 times the square root of 3. And square root of 4 is 2 radical 3, right? Square root 4 is 2, so 2 radical 3. So square root 12 is 2 radical 3. So then 2 radical 3 divided by 2, so that's just radical 3. So 3 has 2 solutions, 3 plus radical 3 and 3 minus radical 3. Again, irrational solutions come in pairs. Now let's see 4. So let's read the question. To understand the question is very important. So we want to find the value of the discriminant. Okay, what is the discriminant? In the quadratic formula, we have negative b plus minus the square root of b squared minus 4ac. We call this a discriminant. We use this delta, like a little triangle to represent. So we want to find a value for this one, for a and for b. Then to analyze, what kind of value of this give us 1 solution, 2 solution, and 3 complex solution or irrational solutions, right? So let's recall quadratic formula. Negative b plus minus square root of b squared minus 4ac, all divided by 2a. So there are 4 cases. Okay, I'll be right back. We have 4 cases. So the first case is, let's write here. The first case is this discriminant to be 0. Well, if this part is 0, we see x equals to negative b over 2a, right? Basically, that's the x value of the vertex. So only 1 solution. Only 1 solution. 2 is a discriminant being positive. Well, being positive also have 2 cases. So let's see, the first case is, let's use A and B. Oh, let's use this. Let's see, discriminant is positive and discriminant can be written as some number squared. Yeah, think of this b squared minus 4ac equals 4. Square root of 4 will be 2, right? If that's the case, we have 2 rational solutions. 2 rational solutions also means the equation is factorable. So it can be written down as 2 factors. Equation is factorable. So that's second case. Third case is the discriminant is positive, but the discriminant cannot be written as someone squared, like those ones we just did, like a square root of 13, right? Square root 13 is different from square root of 16. Square root 16, square root 4, those are perfect squares, but square root 13 is not. In that case, we have 2 irrational solutions with radical signs, but we still have 2 solutions. So once the discriminant is bigger than 0, it's positive, we have 2 solutions. One could be rational solution if the discriminant is a perfect square. Or if the discriminant is not perfect square, we have 2 irrational solutions. So number 4 is a discriminant be negative. Then we have 2 complex solutions, right? Like the previous ones we did. So we have these 4 situations. Now let's check A and B to see which situations they are. Let's say A. So figure out A, B, C. A is a number before x squared, 9. B is a number before x, negative 6. C is a number by itself. Now we have b squared minus 4ac. That equals to negative 6 squared minus 4 times a, 9 times c, 1. Negative 6 squared, 36. 4 times 9, 36. 36 times 1, 36. 36 minus 36 equals 0. So discriminant is 0. That means only 1 solution. only one solution. If we want to find out this one solution, we could do x equals negative b over 2a. Negative b is negative 6. And negative b is negative 6 over 2 times a, 2 times 9. Negative, negative become positive, 6 over 18. Or 6 over 18 can be simplified as 1/3. Right? This is one solution. Well, we said this is the only one solution. That means this can be factored. You see this can be factored as 3x minus 1 squared, perfect square. Right? That indicates 3x minus 1 can be 0. That means 3x equals to 1, x equals to 1/3. All right, so this is through factoring. But this here through quadratic formulas. All right, so basically this is the part we want to show. We want to show the discriminant equals 0. That's only one solution. Okay, let's see B. B will have A equals to 5, B equals to -4. What about C? C, remember we have to move to the other side and leave the right-hand side to be 0. So C is a positive 6. Then B squared minus 4AC equals to -4 squared minus 4 times A times C. -4 squared, 16. Minus 4 times 5, 20. 20 times 6, 120. 16 minus 120 is negative 104. So the discriminant is less than 0. Less than 0, remember, 2 complex solutions. Okay, so that covers 2 cases. Now let's see 5. 5, we're given the solutions for the quadratic equation, and we want to go back to write down the equation. To write down the equation, have this as a solution. So the solution means x equals to 3 and x equals to -2. And we rewrite this equation as x minus 3 equals to 0, and x minus -2 becomes x plus 2 equals to 0. Now this is 0, this is 0. 0 multiplied by 0 is 0. So we can write x minus 3, x plus 2 to be 0. Then we FOIL it. We do x times x, we get x squared. -3 times 2, get -6. We have -3x, positive 2x adds up to be just -x. So that's the equation. So this is the equation, has 3 and -2 as solutions. So basically you see we're going backward. Usually we go this way to solve the equation, right? If we start with x squared minus x minus 6, we can factor into 2 factors, x minus 3, x plus 2. Then using zero property to get 2 solutions. So this is just reverse the process, the steps. Okay, now let's see B. We do the same thing. We see x equals to 5i, x equals to -5i, then x minus 5i is 0, x plus 5i is 0. 0 times 0 is 0. Then x times x, x squared. -5i times 5i, I claim that's 25. Let's see why. -5i times 5i. Negative times positive, negative. 5 times 5, 25. I times I squared. What is I squared? I squared is -1. -25 times -1, positive 25. That's why we have positive 25 here. Now the middle term is I have -5ix, I have positive 5ix. They cancel to be 0. So that's it. Sum of 2 squares. So can be factored as complex factors. Now let's see, lastly, we want to graph quadratic functions by identifying the vertex, the x-intercept, if there are any, the y-intercept, if there are any. So one form of quadratic functions is this: f of x equal to a leading coefficient, x minus h squared plus k. So in this case, h comma k is the vertex. If a is such a is positive, we get an upward parabola, and we have this vertex to be minimum. If a is a negative number, we have this downward parabola. The absolute, the vertex is maximum. Okay. Now let's compare this one. Compare A. We say A equals to -1, right? Because this is a negative sign here. We understand as a -1. And H is -2, right? Because we have x minus h. X plus 2 is x minus -2. So h is -2. K is -3. Remember in the formula, we have plus k, right? So in this case, it's plus -3. So the vertex is -2, -3. Well, x value -2 here, -3 goes down. So this is the vertex, -2, -3. Now let's figure out y-intercept. Remember the definition of y-intercept is x value is 0, right? Y-intercept means the points on y-axis. All the points on y-axis have x value to be 0. So that means we just plug in 0 for the function, looking for f of 0. So we see that's -0 plus 2 squared minus 3. It's -2 squared minus 3. Well, 2 squared is 4, so -4 minus 3, which is -7. So y-intercept is 0, -7. So here. Well, a is negative. Leading coefficient is negative. That means we get a downward parabola. When we graph smoothly, we graph with curves. And the quadratic functions are symmetric. So the vertex is on the line of symmetry, which is x equals to -2. So this line is called x equals to -2. So if I have a point on this, I have to have a point on the graph of this one. So try to graph smoothly. Yeah, I think I graphed this side better, right? So this side should be, this is better use. Yeah, that's the graph. So this graph has no x-intercept, because it goes away from x-axis. We could have complex solutions, but no real solutions if we make this one to be 0. Because x-intercept means the y value is 0, right? It means function value is 0. Function value is 0, we only have complex solutions. No real solution, but this x-axis, y-axis are real number lines. Okay, so this is a graph. No x-intercepts. Y-intercept is 0, -7. Let's see B. B, we're not in the vertex form, but we can complete the squares, right? We can rewrite this as x squared minus 2x plus 1 plus 1. This gives us a perfect square because the -2 divided by 2 is -1. -1 squared is 1. So this one is x minus 1 squared plus 1. Well, that means A is positive 1, H is 1, K is also 1. Oh, all three things are 1. So A is positive, we get an upward parabola. H is 1, K is 1, so vertex, the vertex is 1, 1. So let's graph it. X value is 1, Y value is 1, so that's the vertex. And it goes upward, right? Goes this way. Now we need to find a y-intercept. Y-intercept means f of 0, so x value is 0, so get 2. So y-intercept is 0, 2. Or 0, 2 is here. So that means from this point to this point, that's this. So the line of symmetry goes through the vertex. So x equals 1 is a line of symmetry. So that means I have a point here too. That's the graph. No x-intercept again. Because the graph will never cross x-axis. No x-intercept. Let's see C. C, this one's special. This one is in standard form, also in vertex form. So in standard form, let's figure out ABC. A equals to 1, B equals to 0, and C equals to -4. In vertex form, we have A equals to 1, H, X minus 0, right? H is 0, K is -4. So vertex is 0, -4. 0, -4 is also a y-intercept. So sometimes the vertex and the y-intercept or maybe x-intercept can overlap. And A is positive, so get an upward parabola. Get an upward parabola. Now, if we get an upward parabola, you see this has go across x-axis. So that means we can find x-intercept. X-intercept means the y value is 0, means the function value is 0, right? So 0 equals x squared minus 4. So that is difference of two squares. Solve this, we'll get a positive 2, -2. So x-intercept will get 2, 0, and the -2, 0. So 2 x-intercepts. This one, 2, 0, and -2, 0. So we try to graph smoothly, like a curvish, not a straight lines. Like something like this. Yeah. So this graph opens up, has a y-intercept, and the y-intercept overlap with the vertex, and then we have two x-intercepts, -2, 0, and 2, 0. Okay, so that's today's class notes.